Hi, I'm Dr. K.
Hi, I'm Elise.
Hi, I'm Phoebe.
And hi, I'm Heather.
And we are the STEM Response Team. Hey everyone, it's Dr. K from the STEM Response Team. I spend so much time making fantastic videos for everybody at home, especially during lockdown, and now we're coming out of lockdown, we're carrying on doing all that stuff. But you know what, you've seen me with my fabulous assistants, my two fantastic sons, Che and Oak. And I think it's time for them to take the reins and do their own episode of our Science at Home. Are you ready, boys?
Yeah! Hey guys, it's Che, I'm Oak, and we're the Junior STEM Response Team. And today we're doing an excellent experiment from the STEM Response Team Science at Home book. What you need for this experiment is some eggs, some vinegar in a jar or a cup, and some food colouring. So first of all, we're going to get the vinegar in the jar or cup, unscrew the top, and then carefully place it down and get your food colouring, and then open it up gently and only get a few little drops. Hey Dad, what is vinegar?
It's acetic acid.
Oh, that's a good one. So, after you place the food colouring in, you screw the top back on very nice and firm, and then just gently shake it till all the food colouring has passed through all the vinegar. Now, for this part, you're gonna get an egg, then unscrew get your vinegar jar or cup, carefully get your egg, then put it in there, and you screw it back up. And if you realise from all the egg puns, you guessed it, we're making the bouncy egg.
Sometime later.
We've left the eggs overnight in the jar of vinegar, and you can see the jar's gone all dirty. That's because the eggshell inside has been coming off and sticking. But before we do anything else, we'll have to wash the eggs in a tub of water. Now we have to wash the eggs to clean them off of the shells. Let's get a spoon and take them out very carefully. Yep. Because these eggs are heavy. They look like a rainbow. Oh, yeah. I got mine. I got mine. Oh, they smell like vinegar. Now we're gonna get our hands in there. Ooh, oh, that feels weird. Oh, now we've washed all the eggshell off, and then you can see the egg has completely changed. It's all squidgy. Mine didn't really turn out purple. And you can see it looks like there's veins in there and stuff. Yeah. Like, it looks really cool. Science time! Eggshells are made of calcium carbonate, and vinegar is an acid. When we put the egg in the vinegar, a chemical reaction happens. And that's called an acid-base reaction. Calcium carbonate is broken down into a gas. And that gas is called carbon dioxide. So when you put the egg in the vinegar, you'll see it get covered in bubbles. You might even see it float up and down. Because it's a gas, you'll need to leave your jar open a little bit. Now it's time to test. Now we're gonna test if they're bouncy. Whoa! That was cool. Now we're gonna do them a bit higher, and if they break, ooh, that would be good. But let's try anyway. Oh! Well, everyone, if you can see, well, we dropped them for a height that they didn't survive from. They exploded. We hope you enjoyed our excellent experiment. Bye everyone! Oh, and don't forget to check out the STEM Response Team webpage.
Hi everyone, my name is Heather and today I have a fantastic science experiment that you all can do at home. This is from our STEM at Home booklet, so today we'll be creating crystals.
So let's begin. The items that you'll need are sugar, salt, bicarbonate of soda, warm water, 3 droppers or pipettes, 3 spoons, 6 plastic containers or bowls or cups, a measuring cup or jug, and a marker. Firstly, we need to label the containers or bowls or cups, whatever item we are using, with the words salt, sugar and bicarb. This is so we can identify what solution is in each cup. Now for this bit you may need adult assistance as we're going to be using warm water. We need to pour half a cup or 125 millilitres of warm water into the container. We're going to start with the sugar first for this experiment. Add a spoonful of sugar to the water and stir until the sugar dissolves. Keep adding sugar until no more sugar will dissolve in the water. Once you've done this, you need to do exactly the same with the salts and for the bicarb. Once we have done this for the salt, sugar and bicarb, we can go ahead and start creating our crystals. So for this we'll need 3 separate droppers or pipettes, and we'll need another container or bowl or cup for each substance. So you need to place your dropper into one of the solutions and suck up some liquid and add a few drops of that solution in its new container. And you need to repeat these for the other 2 solutions. Once you have done this, you need to place the cups in a warm, sunny place and leave them until the liquid has evaporated. What do you think we'll see? So you can see here that we have some little crystals that have formed. So, what is happening? When a solid or a solute dissolves in water until no more dissolves, the solution is saturated. The amount of substance that dissolves in the water increases with temperature. As the solution cools back down to room temperature, there is no more solute in the water than there normally would be. So the solution is supersaturated. As the water evaporates, the solute precipitates out of the solution in the form of a crystal. This is an example of crystallization. You will notice that each precipitate forms slightly different crystals. They could be different sizes or different shapes.
So there you have it, how you can create crystals for yourself at home. I hope you'll all try this, and if you do, we'd love to see any of the crystals that you have made. Bye!
Hi everyone, my name is Elise and I'm part of the amazing STEM response team. Now today I'm going to show you how to do a really cool experiment based on biology. We're going to look at the water transport that plants use. All plants need water to survive, just like animals and humans do. But how do plants get their water to drink? They can't use a glass like we can, so there must be a special adaptation instead. Plants have a structure called xylem, and xylem are like little vessels which go from the roots and transport water into the stem and into the leaves of the plant too. And that's what we are going to explore in this experiment. So what you'll need for this experiment is a big stalk of celery. Now you'll want to have a celery stalk that has these nice leafy greens on top of them. Not one like this, one with the nice leaves like this. Secondly, we'll need a glass to use, we'll need some water, we'll need a spoon to mix, and we'll also need some food dye.
First of all, you'll want to cut up your celery. Remember, you want to cut up a stalk that has some nice leafy greens on it. Please have the help of a responsible adult during this process. Secondly, now is the time to fill up your water in the glass. Then you'll want to add your food colouring to your water to make a nice solution. I'm using a black food colouring, but you can use whatever colour you prefer. You might need to use a few drops of food colouring to get the desired effect you want. Stir the food colouring until it's all mixed through the water. Once mixed, it's time to put your celery in the water. Just like this. Leave your celery on a nice windowsill or somewhere bright overnight.
Okay, well it's a new day, we've left our celery overnight and we've come back this morning. So we're going to investigate whether our experiment has worked and if we can see those xylems, those vessels and structures which allow water transportation from the root up to the stem and into the leaves of the plant. So as you can see, our celery is here. It's been sat in our food colouring and water solution for about 24 hours now. The longer you leave it, the better results you should have. If we have a look at one of our celeries, if we take him out, very carefully not to spill your food colouring anywhere on any carpets or t-shirts. And if we have a closer look, there you go. You can just see those vessels called the xylem. Now we're going to cut this piece of celery open and have a closer look to see the insides of this plant's structure.
Cut your celery down the middle with the help of a responsible adult and you should be able to see the structures of the xylem in your celery stalk. Can you see those stripes in our stalk? So those there are the xylem and they help transport water throughout the plant.
Wasn't that just incredible that we could see the structures that plants use to transport their water throughout the leaves and the stem? If you want to try this experiment yourselves at home, please do so with a responsible adult and you can find all the instructions written down in our fabulous STEM at Home booklet, which has loads of experiments including this one called Stripy Celery. We hope you've enjoyed this session and we look forward to the rest of your science experiments.
Hi everyone! Today I'm going to be showing you an experiment out of our STEM at Home booklet. You can find this booklet on our website under the Our Resources section. The use of invisible ink is a form of steganography, and it isn't just used by secret agents. Invisible ink is applied to a writing surface with a specialty purpose stylus, fountain pen or toothpick, even a finger dipped in the special liquid. Once dry, the surface should appear blank and of similar texture to any of the surrounding material. Other uses include anti-counterfeiting, property marking, hand stamping. So for example, if you've gone to an event and they stamp your hand to get in, sometimes that's invisible and it's revealed by a special light. Children's games also use it, and marking for the purpose of identification during manufacturing. So when something's being made in a factory, sometimes invisible ink is used to make sure that you can identify the brand name or the manufacturing number of that product. Today I'm going to be doing the invisible ink experiment. So have any of you ever wanted to send a super secret message to one of your friends or maybe a family member? A message that you can't see unless you do a super secret science experiment to show it? Well, I'm going to show you how to do that in this video. So for this experiment, you're going to need some milk or lemon juice, some cotton buds, a small bowl, and some pieces of paper. You're also going to need a light bulb or a heat source that gets quite warm. Make sure you have an adult to supervise you for this part. So first you're going to have to dip your cotton bud in milk, drip off the excess, and then write your secret message onto your scrap paper. You can write anything you want. I'm just going to write the word STEM because that's one of my favourite words on this piece of paper that I've got in front of me now. Then all you have to do is wait for these letters to dry until you can no longer see the letters on the pieces of paper. So I'm just going to fan mine a little bit to speed up the process. You can also use the cold setting on a hairdryer to speed this up. So once you have that heat source ready, you need to just find that responsible adult I told you about earlier, and you'll have to ask them to place the piece of paper with your secret message over the heat source. So this could take some time, so be patient, and slowly but surely the letters will heat up until you're able to see the secret message again. So there's my STEM paper there. So now you're probably wondering, how did this work? Well, lemon juice is an organic substance that oxidises and turns brown when you heat it up. By diluting the lemon juice in water, what you did there was you made it less noticeable when you applied it to the paper, so nobody was aware that it was there until it was heated up and the secret brown message is revealed. There are other things that work in a similar way to the lemon juice and water mixture, such as orange juice, honey, milk and vinegar. These are all substances that oxidise when heated and therefore change colour. Invisible ink can also be made in labs using different chemical reactions, and certain liquids can even be viewed under a UV or ultraviolet light. So just like James Bond and all the other awesome super spies out there, you won't only be able to write secret messages, but if you ever come across one, you might even be able to reveal one yourself. So if you all enjoyed making this super special spy invisible ink, there are loads more scientific experiments on our website. So if you go onto that part of the website and click on our resources, you can find loads of different resources, worksheets, videos, including our STEM at Home booklet, which is where you can find loads of different experiments that you can all get up to at home. So from rubbery eggs that can bounce off the walls to stripy celery, there are lots of really cool, exciting and fun experiments on our website, so go and check it out. Thanks for watching. Bye!